Hey, it's T. I'm one of the geniuses at AskZylor. So let's just get started with the live session. So again, different from last week, we have a webcam now, so you can actually see my face and we can interact. So please feel free to send us any messages and we'll be happy to help you out if you have any questions or if you're struggling with this question in particular. So we're going to start the first question. So again, we're doing some calculus for this section. And then we're going to have another live session in about 30 to 40 minutes, and we'll be doing some vectors then. Okay. So our first question is, how can you tell that these men are moving in opposite directions without solving to find their velocities? So we know what their velocities can be because we can find the derivative of these position functions, and then we can find their velocities and see if they're moving in opposite directions. But this question is telling us we can't solve to find their velocities. We have to solve it in another way. So what we can do is look at what my highest exponent is in each function. So I have 5 and 3. So without explicitly solving the derivative of each of these functions, what I'm going to do is see what the highest exponent for my derivative is going to be. So if I take the derivative of 4t5, for example, my exponent is going to go down by 1. So in both these cases, I have an odd number. So if I do -1 to an odd number, it's going to become an even number. So my 5 is going to be 4, and my 3 is going to be 2. So regardless of what I put into my t value, I'm going to get a positive number because of my big exponents, 4 and 2, my even exponents. So what's going to determine if my velocities are moving in opposite directions is my coefficients in front of my variable. So I have +4 and -8. So my +4 means that any number I put into t is going to give me a positive number. My -8 tells me that any number I put into t is going to give me a negative number in my derivative. So what this means is that when I look at my velocity, my derivative of each of these functions is going to have the highest exponent of 4 and 2. So the only factor that's going to affect my positive or negative sign is going to be the +4 and the -8. So what I have is my velocity is going in opposite directions, and then if I were to take the derivative of each of these constants, it's going to be 0. So they're not really going to affect my answer at all. So how am I going to solve this? I basically looked at what could my exponent for my derivative is. So for each of them it was 4 and 2, which are both even. So they're not really going to affect my velocity. So I'm just looking at my coefficients, and I saw that -8 and +4 are going to affect the velocity. So that means my positive coefficient is going to move. My velocity is going to move in a positive direction, and for the man 2, my velocity is going to move in the negative direction. Do you guys have any questions about this? It's a very conceptual question. There's not really much work to be done. We're just exploring what we can do with exponents and how the derivative of these exponents are going to influence my velocity and the direction of this velocity. So once again, we're going to do some calculus for this session. We're going to go through some common problems you might find that you might encounter on a test. And then we're going to solve them. If you have any questions that you want us to solve, please send them in, and we'll be happy to either answer them for you or show how to do them on the live session as well. So we're going to move into our second question, if you guys don't have any. So a second question says, find the absolute extrema of the function g of t in the interval -4 and 2. So how do we do this? We basically need to find where the absolute extrema is of g and t, and we have to evaluate this function at each of these intervals as well. So this interval basically means t needs to be evaluated at -4 and 2. We also need to see when is g prime of t going to equal 0, because that's going to tell me where the local minimum and maximum are. So let's go ahead and find what the derivative of g of t is. So g of t is going to be 6t squared plus 6t minus 12, and my plus 4 is going to give me a 0 when I derive it. Alright, so then I'm going to make my derivative equal to 0, and then I'm going to try and factor this equation. So then I'm going to take out 6 from each of these terms, so I have t squared plus t minus 2. And then I can do t plus 2, t minus 1. So when is my g prime of t going to equal 0? When t is equal to -2 and when t is equal to 1. So I also said we need to evaluate the endpoints of this interval, -4 and t, -4 and 2. So we have 4 values in total we need to evaluate. We need to find out when g is going to be -4, g is going to be -2, g is going to be 1, and when g is going to be 2. So I'm going to write down the equation for g of t. So it's going to be 2t cubed plus 3t squared minus 12t plus 4. So instead of t, I'm going to sub in my -4 value. And that's going to give me -28. So I'm going to do this step just to save some time. I'm not going to do all the work for them. But if I did make a mistake, please let me know. So then I'm going to do the same step for each of these t values. So I'm going to plug -2 into g of t, 1 into g of t, and 2 into g of t. So g of -2 is going to give me 24. And g of 1 is going to give me -3. And g of 2 is going to give me 8. So based on these values, the question is asking us to find the absolute extrema of the function. So we need to find the absolute maximum and the absolute minimum. So based on the values we've analyzed -4, -2, 1, and 2. We're going to look at what are my y values. So I have -28, 24, -3, and 8. So out of these, which is my highest number? It's going to be 24. So I have -2 and 24 as my maximum. And what's my smallest number? I have -28. So I have -4 and 28 as my minimum. So my absolute minimum is going to be when t is equal to -4. And my absolute maximum is going to be when t is equal to -2. You guys have any questions about this? So for those of you who are joining in right now, we're going through some calculus questions, so we're getting into the introduction of optimization. So we'll be getting into more complicated questions, some application and thinking questions. And if you are doing vectors right now, we'll be having a second session around 8:30, 8:40, where we'll be tackling some vectors questions, some common questions you'll encounter on a test. So the question we just answered was find the absolute extrema of this function in the interval -4 and 2. So we analyzed each of these endpoints. We found out when this derivative was 0, and we found out t values for when that function is 0. And then we analyzed all of those points in my original function to find my maximum or minimum function. So I found that my absolute minimum was at t is equal to -4, and my absolute maximum is when t is equal to -2. Any questions before we move on? So once again, you can send us your questions through messaging us, or you can ask us in the live itself. Don't be shy, we're not going to say who the question is from, so we'll make sure to keep that anonymous. So we're going to move on to the next question. So our next question tells us that we're given an object moving on a straight road. It has a position function s of t. How long does it take to reach its maximum velocity between 0 and 6 seconds? So once again, when we're analyzing the absolute maximum or minimum, we need to evaluate the endpoints of the interval as well. So we need to see when is t is equal to 0 and when t is equal to 6. So the first thing I do is I need to see what my velocity function is. So I have my position function, so I'm going to find my velocity function because that is simply the derivative of my position function. So that's going to give me -12t squared plus 24t plus 2. But I'm not done because they're asking me what is the maximum velocity. To find the maximum velocity, I need to go and find the derivative of my velocity function. And then when the derivative of my velocity function is equal to 0, that is when I can find my maximum velocity. So let's go ahead and find the derivative of my velocity function. So that coincidentally is also my acceleration function. Right, so let's go ahead and derive this. So I'm going to bring the exponent down, multiply with my coefficient. So then I have -24t plus 24, and then my 2 is going to give me 0. Right, so I said I need to find when is my derivative of my velocity function equal to 0. So I'm going to say 0 is equal to -24t plus 24, and then my t is going to be equal to 1. Right. So I have to test two of my endpoints, which is t is equal to 0 and t is equal to 6, and what I found through my derivative. So I have to find when v is 1, v is 0, and when v is 6. So I'm going to write down my velocity equation again. So I have -12t squared plus 24t plus 2. Right, all that is going to give me 14. I'm going to skip some steps again. I'm just going to plug in 1 into each of my t values. And then v at 0 is going to be 2. And my v at 6 is going to be -286. So they're asking me what is my maximum velocity, so I don't care about the smallest number, I only care about the biggest number. So my maximum velocity is when t is equal to 1, I have 14. So that is my answer. When t is equal to 1, I have my maximum velocity between 0 and 6 seconds. If they were asking me what's my minimum velocity, it would be t is equal to 6, because that's my smallest number again. Any questions so far? So once again, we're doing some optimization questions from calculus. So if you guys are just tuning in, We'll be doing another live session at around 8:30 or 8:40. So we've finished a simple optimization question, and we've moved on to an optimization and a little bit of application. We'll stick with that, and we'll move on to the next question, which has more optimization questions. And particularly, there'll be optimization and some applications of optimization. So let's get started with this question. So it's telling me Farmer Ben would like to enclose his pig pen with fencing. He has 180 meters of fencing. In order to save material, he will use the side of his barn as one side of the pen. If they're trying to maximize the area of his pen, what dimensions should he use? So let's go ahead and draw a simple diagram for that. So let's say one side is going to be Ben's barn. And then I have two lengths and a width. So they've told me that my perimeter is going to be 180 meters. And then the sides I have one width and two lengths. So I'm going to simplify this to width is equal to 180 minus 2L so that I can plug it into my area equation. Because they're saying to maximize the area. So my area equation is simply length times width, but I have two unknown variables, so I'm going to simplify that by plugging in what my W is equal to. So my area is equal to length times 180 minus 2L. And then we have to maximize the area. So I've come up with an equation that gives me area in terms of length. So I'm going to write that more clearly, 180 minus 2L, and that's going to give me 180L minus 2L squared. So if we were to maximize the area, that means we have to find the derivative of the area function and equate that to 0 and solve for my L, or my length. So I'm going to do just that. So I'm going to find the derivative of my area. So that's going to be 180 minus 4L. So then I'm going to equate that to 0, and then I'm going to solve for what my length is. So my length is going to be 180 over 4. In other words, 45. So now I found my length, which optimizes my area, which finds the maximum area possible. But I do want to check my answer. So I'm going to look at when my W is equal to 180 minus 2L. My length or my width can't be a negative number. So my length has to at least equal 0 or bigger. And the biggest number would be my width can't equal 0. So if I make 0 is equal to 180 minus 2L, my length is going to be 90. So this is the maximum possible number, and this is my minimum number. And this is what I found through the derivative. I'm trying to find maximum area. So I have 3 points I need to check. I need to check when A is equal to 0, when A is equal to 45, when A is equal to 90. So I'm going to plug all this into my area equation, which I did earlier. So it was 180 L minus 2L squared. So when I plug this in, I get 0. When I plug in 45 into this, I get 40/50. Then when I plug in 90 into both of these, I again get 0. So what's my maximum number? It's going to be when A is equal to 40/50 and when my length is equal to 45. So if my length is equal to 45, what's my width? I came up with an equation before. It's 180 minus 2L. So that's simply going to be 180 minus 2 times 45, which is going to be 90. So I have my dimensions for Farmer Ben's pen. My length is going to be 45, my width is going to be 90. So what we did was we had to maximize the area given a certain amount of fencing. So I drew a small diagram just to illustrate what we're trying to solve. We have two lengths and a width, and one side is using Ben's barn as one of the sides of the pen, and then I came up with an equation for perimeter as isolated for my width, and then I came up with an equation for my area in terms of one variable, which was length. And then I went through and found the derivative of my area function, and then I came up with the length. Do you guys have any questions about this? So once again, we finished some optimizations questions, some applications of optimization, and then we'll have another live session doing some vectors. So please feel free to send in any questions you have regarding these problems. If you're unsure, I can go over them again. Amazing. So we'll just get started with the next question. So this question is saying we are given a graph of the derivative of f of x. For what values of x does f of x have a local maximum or local minimum? So what we're going to do is, we know when, I should use a different pen. When my f prime function is equal to 0, my f of x function is going to have either a local min or max. So first thing I'm going to do is identify all the points when f prime x is equal to 0. So that's going to be here, here, and here. So that's when x is equal to 1, 3, and 5. So what we're going to do is basically analyze what the derivative function is, how it's behaving around each of these zeros. So at f prime 1, we're going to see what's happening on the left and the right hand side of this value. So what happens is, when x is equal to 1, my f prime graph is positive on the left hand side, and it's negative on my right hand side. Right? All I'm doing is I'm looking at what's happening here and here. So it's positive on my left hand side, negative on my right hand side. What that indicates is I basically, on my left hand side, I basically have a function that looks like this, which means my rate of change on my left hand side has to be positive, and my rate of change on my right hand side has to be negative. That indicates I have a maximum. So at f prime 1, I should have a maximum. So we're going to move on to the next value, which is x is equal to 3. So I'm going to do the same thing. When f prime is 3, I'm going to look at what's my value on my left-hand side and what's my value on my right-hand side. So on my left-hand side, I have a negative. On my right-hand side, I have a positive. So if you're just joining in, we're doing some curve sketching right now. We've moved through some optimizations questions, through calculus, and we're just analyzing some graphs right now. So I found that at f'1 I have a maximum, and then at f'3 I'm trying to see if I have a maximum or minimum. So if left I have a negative number, and if on my right I have a positive number, my original function should not have something like this, it should have something like this. Why? Because on my left hand side I have a negative value, so my rate of change should be negative. On my right side I have a positive number, so my rate of change should be positive. So what that tells me is that point is going to be a minimum. So we have one last point to check, so f prime at 5. So we found a maximum and minimum already. So at f prime 5, what happens? On my left side I have a positive, on my right side I also have a positive, so there's no real change. So if there's no real change, I have plus and minus on my left and, plus and plus on my left and right hand side. So what that means is we have no maximum or minimum. So there's no local extrema at f prime at 5, but we do have a local maximum and a minimum at f prime 1 and f prime 3. So that's how I basically do some curve sketching. That's how I could use what I know so far to do some curve sketching later on. But if we're evaluating just this function, what I initially did was I need to find out when f prime x is 0, so I identified 3 points. So x at 1, 3, and 5, and then I evaluated what my f prime values are on my left hand side and right hand side of each of those functions, each of those points. And then I evaluated my original function and the rate of change at those points to see, is it going to be a maximum or is it going to be a minimum? So any questions about this? So once again, we're doing some calculus, we've done some curve sketching, we've done some common problems you might see on a test. So we did some optimizations questions, some applications of optimization, and now we've done some curve sketching as well. So we'll talk more about curve sketching next week, or I guess this Wednesday, because we'll be doing another live session this Wednesday. So we'll move forward and hopefully your school will be caught up and we'll be doing some curve sketching, and then we'll be doing another live session right after this to answer some vectors questions. So any questions so far? Perfect. So that's about all the questions we have so far. So give me 1 second. There we go. So we've covered some calculus, we've gone through some common problems you might see on a test, so we're going to do another session for vectors very soon. So if you do have any questions, please send them in, but we're going to end this live session right now and we'll get to some vectors questions in a bit. So once again, my name is Delina, you can call me T, I'm from AskZylor. If you guys are new and you guys just joined in, we are service dedicated to helping students out. If you have any questions, send them through DMs and we'll be happy to answer.